Okay, so this is my tabulation which I have mentioned to you. Now, as you can observe that the left hand side, what you are observing over here as under N by B, this is basically your channels. These all are your channels and the respective probabilities are given over here. So the 0.01, 0.05, 0.1, 0.5, whatever it's given, this is basically the probabilities to it. Now what I am trying to do is, we are going to achieve with respect to this particular problem, we have 20 channels. So we'll go and check for 20. So this is my 20. Now you have to find what is the 2% probability. So this is your 2% probability. So wherever it intersects, so it is around that 13.18. So if I can't mark it in PDF, but if I come across this, so this is my 13.18. So ideally, if I go back, so I will write that for C equals to 20 and with a given 2% of probability, we can have the maximum achievable intensity, traffic intensity, and that is to be 13.4 if I am not wrong with Erlang. So this is my total A. Now the question that is asked for is to find out how many number of users that it can support. Now if you know A, okay, and if you know lambda, and if you know H, can anyone give me the answer for how many number of users? You will just need to use the equation, whatever we did. We did 3 equations, right? One was capital AU, which was given by lambda multiplied by H. We did one with capital A, which was equal to U multiplied by AU. And last one with traffic intensity per channel, where we divided with number of channels. So just find out what is capital AU, okay, which is nothing but lambda multiplied by H. Change the respective, because one is in minute, the other one is hour, so you change it accordingly, and this will come around 0.1 Erlang. Change it in a single unit, that is. One is given as 2 calls per hour and the other one is in minutes, so you can convert that into minutes and you can do that. So this is your AU. So if you know that, so total number of users per cell is given by 13.4 or 13, whatever you call it, 13.4 divided by 0.1. So this is what we are doing. We are doing just the A by AU part, because this is equal to U. So this will give you the user, which is around 130 user per cell. So whatever, first thing to know is that in the given question, we have to find out that what are the 2 components given of Erlang. Either the probability and the channel will be given, the intensity you have to find out, or you have to find out the intensity. I will show you the next problem actually. The intensity and probabilities will be given, so you can write down the number of channels that is available. In this case, what we did, we found out that whatever is happening, it's only for one cell. So this is the total number of users per cell. Please remember this also, because this is not the overall user, because whatever we are calculating, it is only for one cell. Now suppose we have total number of cells as 100. So the total user in the cellular coverage, total user all throughout, is given by 130 user per cell multiplied by 100, and that is coming around 130. So this is the total number of users in the whole cellular coverage. That is what we do. So if suppose the cell number of cells and all those things are not given, then you can say that this is the total number of users. But since in the given question it has to be multiplied 100 times, so you are having the total users. Now using the same process, can you find out what happens with 0.1% of crosstalk? Because that will give you the third answer. Can you observe any significant difference in the data? So using the same tabulation, if you are carrying with you, how many of you carrying with the data? See, one per bench is right, is cost. So you won't be able to do it, because that's the same thing happened in exam as well. If you are not carrying your tabulation, you cannot take just some arbitrary values for your results. So The answer won't come. So 0.1, if I consider that, what will be the value? For 0.1 blocking probability with 20 channels, what is the value you are getting? 9.41. Okay, so I am not writing it over here. So when C equals to 20 and your blocking probability is 0.1%, so your capital A is coming around 9.4 Erlang. So if you have 9.4 Erlang and then divide that by 0.1 because the rest of the things have remained same. So 9.4 divided by 0.1, so it's like around 94002. So 9. So it should be total user. This is this throughout. So total user all throughout will come around 9400. So now you can observe one very important observation. Yes, one very important observation that when you are considering the fact you have 2%. Is it correct that 9.0? Can you check it for? Because ID, okay. If I consider, yes, it's correct only. 9400 is correct. Can you observe the significant difference? See, when I am considering, what can be the comment from this? The first one had 2% of blocking probability. The second one is having 0.1% blocking probability. So naturally, the second case, we have least blocking probability. So if the blocking probability is low, naturally it indicates that the total number of users that it can support is also lower. Because the lesser is the user, the lesser is the requirement for a call. Understand? Here you can see in the second case when it is 0.1, so you are compromising the total number of users, okay, per cell as well as all throughout the coverage when you are considering a 0.1 blocking probability. But if you are increasing the blocking probability that I am happy with 2% of calls getting blocked, then actually you can accommodate more number of users. This is what we call as the grade of service. That which one to choose. If my network, I want to have a blocking probability that is less. If that is my primary objective, then I have to compromise with the number of users. I cannot go beyond 9400 with the given specification. But if I wish to include more users, naturally there is a chance that more calls will get blocked, which is quite obvious. So Erlang B calculation gives us the optimal solution or optimal value to the number of users that can be through the path. Am I clear what the idea is? This is the objective of Erlang B. Now suppose you design a system and you don't follow Erlang B formula. You want to have 0.1 blocking probability and you want to have 15,000 odd users in the machine. Then can you just do it, or I think do the reverse way around. If it is 15,000, suppose you just do it. 15,000 if the total number of users is there. So 15,000 divided by 100. So per user is 150. Okay. So it is 150. So 150 multiplied by 0.1. Do it. How many channels? 28 channels you need. So basically you have to increase the number of channels. If you go back to the tabulation, so now you have capital A, you have the probability as set as 0.1%. So you have to increase the number of channels, which I said as 28. So 20 to 28, so 8 more channels you need. Otherwise, it's not possible. You cannot really just go on blindly increasing the user. It can't happen. It will definitely increase the call blocking capacity. That is the main objective behind Erlang B as well as for Erlang C. Okay? So this is one of the first problem on Erlang B. This is much simpler. So let us go ahead with a little bit of twist in the. But this is a concept. We have to follow the same thing. Even in numericals, you won't find that lambda equal to 2 or the average duration of the call. This will be not given directly, like in this case. So let's see the statement of the problem, how it will change. So we'll go and this tabulation, whatever you are looking at, they are all coming from the graphs like this. As I told you last day that this graph, we won't be following it. Whatever the values we got, that approximate values are given in the tabulation. So you will follow the tabulation. So let's see whether we can do this problem. Just check this thing out. It's a very, very interesting problem, and I would like you to just look into the problem one and then you try to solve it, because the solution is very simple in a way, but understanding our first step is what to do. So please read it. In a cellular system, the average calls per hour in one cell is 3000 and an average calling time is 1.76 minutes. Okay. If the blocking probability is 2%, find the offered traffic load and maximum number of channels needed in the system. If the average number of calls per hour in one cell increases to 3072, it should be increases to 3072 with a blocking probability of 5%. Find the maximum number of channels required in the system. From the earlier question or the earlier solution that we had, how to approach anything like that? What are the two things you have to find out? That's very important. Find the offered traffic load, so that's basically your capital A. Please note down this offered traffic load will indicate traffic intensity. We are looking at traffic intensity for the timing, but this is all again synonyms. So you have to identify that whenever it's given offered traffic load, it's basically equivalent to finding the intensity. So offered traffic load is one. Second is maximum number of channels needed in the system. So C is also on. Okay, that is because we are calculating. See here in one cell. See here you don't have to multiply or anything. That's what I told you. Last problem we had 100 cells, so we have to multiply. In this case, it's one cell only. So you have this generation. So if you wish to, first of all, tell me which Erlang B or Erlang C, which one to use? B, because it's given directly. The blocking probability is 2%. So identification 1. That it's an Erlang B problem first. Now, as I told you that in Erlang B, there are three components to it. Okay, so please remember this. So either it should be A, the second component is the probability, and the third component is the channel. Ideally, you need two information to find the third one, like we did the last problem. But unfortunately, in this particular problem, it is asking for both A and C, given only one condition of 2% is given to you. But are there any other way to find out that what will be A or C given the specification that we have? Can we approach the problem? Because all the information is given to you. There is a specific assumption in this problem that makes this problem a little twisting in nature. So, can anyone just identify or at least have a thought? Just take 2 minutes to read the question. Because you can see the channel and the probability are like directly related to the Erlang B. But we have some kind of a relationship with capital A with respect to the user as well as the user intensity, traffic intensity per user. So is there anywhere lambda, H or these things are given to you? Holding time is given to you. Holding time is given to you. It's calling time, average calling time. So this is again one synonym. So when you are inside of holding time, you are looking at calling time. That is also synonymous to holding time. So if suppose you are not able to find holding time, so that is another way of representing. So 1.76 minutes is basically the holding time. Correct. But is there anywhere the lambda or the calling rate or the request rate to use? it says average calls per hour, correct? Average calls per hour as 3000 per cell. So, what can it be then? How does this 3000 come to? Is it per user? Is it per user or for the overall? Because per user 3000 is an ambiguous term. Per user, one user cannot call, so 3000 calls per hour is impossible. It's basically giving us some kind of an information on the total number of users who are making an average call of 3000 calls. That can be possible. If there are multiple number of users, that can be possible. So if I write this, first I write and then explain. So average, this is the only step, only the step which is important in this case. Average call per hour per cell, if I write this as 3000 and if I equate this to U lambda, can I write this? U is the total number of users and they are making a request rate of lambda. Suppose they are making a request rate of lambda. So U lambda is actually given as 3000. This is the only most crucial step in this case. So if now I write A, which is U multiplied by lambda multiplied by H, because AU is again lambda H. In this U lambda you can write as 3000 and H you can write as 1.8. So can anyone substitute the data and give me the first of all capital A what you are getting? Then we will find out the result. Because that's the only step, that 3000, identifying the 3000 as U lambda. Since there is no request rate is given to us, that is the only concept that we can have. That is the only assumption we can take. Please make sure that you change it into the same unit before solving it, because one is given in minutes, the others are in hours. So all convert to the same unit. 80? Everyone is with 88, 88, 86, 88. Okay. So let me consider that as 88. So this calculation is giving us some value of 88 Erlang. So this is my traffic average or offered traffic load per cell with respect to the given specification. So this is my A. So now you are having A. So in this case you have A, probability is 2%. So can you give me the entry value of the channels? 15 channels. 2% blocking probability. Anyone with the tabulation? Check it properly. $100 channels, is it? Tentative, I'm not. People at the back, the total number of channels I need. If you have an intensity of 88 Erlang, you have 2% blocking probability. What will be the total number of channels? Just check it. How much? 100 channels. So basically your channel is coming around 100. So if you have 100 channels and you have the respective specifications, then you can actually provide an intensity of 88 Erlang. Now the question is, if you have the call to be as 3072, it has increases to 3072. Okay, naturally you will have a different set of values. So can you do it for 3072? So do the same way. So now the number of call has increased, but we are keeping the call blocking probability as 2%. $95. Okay, so in case of the second one, they are calculating as 95 channels. When the number of call increases to 3072, your channel which is required is 95, keeping the call blocking probability as 2%. Okay? Sorry, 5%. Sorry, 5%. So you are increasing the call blocking probability. Hence, you are making sure that for 5, you cannot compare basically because 5 and 2 you cannot compare. But for increasing number of user call, 1 call per hour, 3072 calls per hour, and with a blocking percent of 5%, you actually can accommodate the same with respect to 95 calls. So that is the beauty of it. So any given problem you can solve using this. Please remember that ideally you need 3 information: intensity, probability, and the channel. Any 2 should be given somewhere. The third one will be unknown. Is it fine with this problem? Because the third one you will do it. I will not be doing it. Am I clear with this problem? It's very important. Yes. 95. We never did nothing. Instead of 3000, just substitute 3072. U lambda prime, suppose this whole thing is 3072 instead of this. Okay, and the respective the lambda, the h and all, they are remaining same. So calculate and get some value of a prime. A prime, what was the bottom of the value? 90.1. Whatever, 90.1 Erlang. It will come around this. So 90.1 Erlang and 5% blocking. Understood? So 90.1 and 5% blocking you map and get the corresponding sign. Same. So if you are done with these 2 problems, can anyone solve this third one? This is up to you to do it. I'll not be doing it. Please come up with the exact answers. A cellular system uses a cluster size of 7. It's operated with 660 channels, 30 of which are designed for control channels. So there are about 90 voice channels available per cell. If there is potential user density of 9000 user per kilometer square, so here the user is given somewhere, and each user makes an average 1 call per hour, and which lasts for 1 minute during peak hours, determine the probability. So here the probability is unknown. So the other 2 problems had probability. Here the third problem we have to find probability. So either the first thing should come to your mind that you have to have somewhere the intensity in the channel. These 2 should be given, or somewhere you have to find out, because the third one is the probability, that is you have to find. So determine the probability that a user will have to experience a delay greater than 20 seconds if all calls are queued. So this is assuming the radius of 470 feet. So you have a cluster 7, total number of channels are given, total number of users are given, lambda and h also is given somewhere. So the question is to find the probability of user experiencing a delay greater than 20 seconds. So the first question that comes to our mind, which formula we are going to use? Which formula means either it's Erlang B or Erlang C. This is the question. Which one we need to choose? Erlang C, why? Because we have a delay. So the first identification point is that it's an Erlang C problem. Because here at the end it is asking for how much the call will get delayed. Since delay term is there, we will have the Erlang C. Fine. Again for Erlang C, you have 3 components: traffic intensity, channel, and the probability of delay. So you are trying to find the probability of delay. So naturally, the A and C should be found out somewhere. Since C is given in a way, the only thing that is left is to find what is capital A. So can you do that? I will not be using it because the same equations you have to use. So use your skill with the given specification and come up with it. this is where we start. We have to find out capital A. So this is the only equation that relates U and AU. What will be U? This is given 9,000 users per kilometer square. Is this the total number of users? You have to multiply this with the area of the cell. Area of the cell formula. Okay. So we'll start by one. So area of a cell, if you take that 3 root 3 and on, so it will come around 2.5981 multiplied by r square, and that will be 0.574 kilometers square. So this multiplied by the total number of users per kilometer square. So the total user is 9,000 multiplied by 0.574. This is 5167 users. So this becomes your U. So 5167 multiplied by 1 by 60 multiplied by 1. I'm changing to the different unit, same unit. And this is coming around, as per my calculation, it will come around 86.1%. This is my capital A. So again, as I told you, that for any given problem for Erlang B or Erlang C, two things are important: channels and the intensity. In this case, intensity, because the probability is unknown. So, how many channels are there? Yes. So we have here, you can see specified properly that out of 660, 30 of which are assigned to control channel. Why it is 90 then? How come these 90 voice channels are coming? 660 minus 30. 630 divided by 7. Ideally, in a given problem, it might be called you that 660 channels are given, because that's it. Nothing, and 30 of which are designed and control channel. This half might be omitted. Then you have to find out what are the number of channels for the voice. Here it is directly given that there are 90 voice channels, but ideally 660 minus 30, that is 630, are the total voice channel all throughout the coverage. Now you have cluster 7, so you divide by 7, so you get 90 odd channels, so that is 90. C is equal to 90. So now for 90, we know the intensity. Now we have to find out with respect to Erlang C what is the probability. For that we will use the formula, as you all know. So probability of delay greater than 20 seconds, because that's what the t is. You remember in Erlang C small t was there. So this is my t. This is equal to probability of delay greater than 0 multiplied by e to the power minus c minus a multiplied by t divided by h. Because this half is nothing but the conditional probability that we have. So just substitute the value, because this probability of delay greater than 0, this you will get it from the table. For 90 channel and intensity of 86.1, find me the probability of delay greater than 0. This half you will get it from table. Please check the Erlang C table now. And for 86.1 Erlang and 90 channels, is there any information given on the probability? It's not given, I guess. Okay, 83. If it is 83, like in this case, if suppose this happens in your exam, that you are coming to a conclusion that your probability is not given in the table, then take the last one, whatever is present. In this case, don't take it, because I will give you the value. This value should come around 0.5. So this is 0.5. This probability from the tabulation, it should come around 0.5. Since here it's not given, you can take the last value, whatever the probability is. So that's 0.5. Evaluate that e to the power part. E to the power minus c minus a. Channel is given, intensity you have found out. intensity you have found out, T and H is also given. So just substitute and find out what is the probability of delay greater than 20 seconds. What is the value? 0.5 multiplied by e to the power minus whole in bracket c minus a multiplied by t. C is 90. A is 86.1 divided by t is 20 seconds and h is also given multiplied by 20 divided by h. H is around 60, I think 1 by 60. It's 60. It's 60. 60. So that value, if you can compute, it should come around 0.136. This is if you change it to your percentage, it will be around 13.6. So that is the probability of a delayed call which needs to be waiting, or the user will experience a delay which is greater than 20. So this is how you are going to solve it for Erlang C. It's the same process, only the calculation is different and the formula that you are referring to is different. So please remember that in this formulas, first half will be taken from the table, the rest is have to be calculated using the data which is. So this is one given numerical for Erlang C. This is something different. Check that. This is another flavor of the problem. For a 7-cell use pattern, by this time we are only doing it for omnidirectional. Now suppose the omnidirectional gives rise to sector. Then what will happen? So for a 7-cell use pattern with with call blocking probability of 1%, average call length of 2 minutes, find the traffic capacity loss. Loss due to trunking for 57 channels when going from omnidirectional antennas to 60-degree sector antennas. Assuming that block calls are cleared and the average calls rate is 1 part R. So again, it's an Erlang B formula that you are referring to. But the only difference in this case is that we are trying to compare the result between omnidirectional antenna to a sector. Now, if you can remember, I'll just wrap up because the process is almost the same. If you can remember in sector antenna or cell sectoring when we discussed, one idea I told you that the channels, the number of channels which are allotted to a particular cellular coverage or in a particular cell, if you consider, that should be also be divided into different sectors. So channels per cell will give rise to channels per sector. So here also you have 57 channels. These are all your for omnidirectional antennas. Now you have 60 sector is 60-degree sectoring. So if it is 60-degree sectoring, so this is, please note down this. If so 60-degree sectored antenna, this will be how many sectors then it will be? 6 sectors. So 6 sectors are present. So naturally your 57 channel will now be divided into 6. So it's almost around 9.5 channels per sector. Please note down this because this is something different to what we did. So now these channels per sector. Now 9.5 cannot be a channel. It should be a whole number. So ideally we have to take around 10 channels per sector. Because this is for calculation. Because if you follow the table, there is no fractional channel. Channel cannot be fractional. 9 you cannot take because it will leave out the 0.5 part. So you can only take 10. So 10 you take as channels per sector. So if there is 10 channels per sector and given blocking probability as 1%, can you give me the intensity A? 10 channels, just check 1% blocking probability and 10 channels. What will be the 4.46. So 4.46 Erlang is the intensity of traffic. Right? So this is your offered load from Erlang B. So the number of user that it can support, the sector, is given by 4.46 divided by 1 by 60 multiplied by 2 is coming around. This is user per sector we are looking at. This is number of user per sector, because whatever we are calculating is per sector. Then we will multiply it with the number of sectors. That will give you the total cellular coverage, number of user per sector. So number of user per sector is 4.46. So this is what we are doing. This is nothing but A by AU. This is what we are doing. Nothing more than that. What is the value you are getting? 4.46 divided by 1 by 60. Around 123. 133. 134. So 134 user. So this is per sector. Please remember, this is where it's important. This all we are calculating per sector. So there are 6 sectors. So the total number of user U is given by 134 multiplied by 6. Please do it, because this is where you will get wrong. You will keep the answer as 134. You make a mistake here. So 134 into 6. So tell me your answer. Sorry? 804. So this is your total user. What will be the total user when it's omnidirectional? Can you find out? How will you get that? For omnidirectional, how many number of users are there? Yes, correct. How many channels will be there for omnidirectional? 57 channels. So you have 57 channels and you have 1% of blocking probability. Find the intensity. So that will be your capital A. Okay. So your A will be, I think, 44 point something. It should be 44.24. Like that. So based on that, if you calculate the user, as per my calculation, it is coming around U prime, if I write, 1326. Approximately. So this is your user, which is with respect to omnidirectional. This is for omnidirectional. So can you calculate the loss, which is quite easy? So 1 minus 804 divided by 1326, and you take a percentage of it, some percentage it will come. So that is the amount of loss that is happening when you are coming from an omnidirectional to a sector. That's what I told even during sectoring when we were studying it, that it is nothing to do with the number of users. It always reduces the amount of the traffic capacity. Because remember, sectoring is only used to improve the signal to interference ratio. It's nothing to do with the user. So here basically when you are doing a trunking of 57 channels into 6 sectors, you are losing out some of the users. So that is being proved. So we have done 4 different types of problems, all relating to Erlang B, Erlang C. You can follow these problems, and I will upload more problems in fact in my course page. So that will be. So we finish off with the first module. We will start with the second module next.